as the systems become smarter, the computation requirement goes up and it fuels requirement of electricity or the energy as such.
The big idea is basically AI doesn't have to be on the cost of the planet. We are finding smarter ways to build it so that they are also more sustainable towards our planet and are more greener.
AI can transform our grid, but only if we build it on a foundation of transparency, accountability, and security.
Namaste.
Namaste.
Hello, and welcome to today's episode where we enter search into one of the most pressing and powerful intersections of our time: brains and batteries, AI fueling the energy transition. I'm your host Deepika Upadhyay, and today we will explore how tech leaders, policymakers, and innovators are shaping a more sustainable and smart energy future. As the world races towards net zero goals, artificial intelligence is no longer just a tool. It's becoming the brain behind the battery, the algorithm behind the action, from optimizing power grids to managing renewable energy flows and predicting energy demands in real time. AI is revolutionizing the way we generate, store, and consume energy. And to help us decode this electrifying convergence of AI and energy, we have with us Dr. Naresh Bana, an international advisor on public-private partnership, sustainable strategy, and infrastructure finance. Dr. Bana brings a wealth of experience of today's complex conversation. We also have with us a very special guest, engineer Kanamal Bhaskar. She is a former superintending engineer with the Tamil Nadu Electricity Department. She has made significant contributions to the state's power infrastructure development policies and projects. We are honored to have her with us on the show. A trailblazer at the forefront, we are also joined by Mr. Aman Gupta, a senior software engineer at Amazon. Mr. Gupta is known for his sharp technical insight and future-focused thinking. He brings a rare blend of hands-on expertise on strategic vision to the world of AI and software engineering. Let's begin with a first question. Dr. Bana, how do you see the relationship between deployment of AI systems and energy demands of a country? What is the global situation as we talk now? Are we at a tipping point or still laying the groundwork?
Thank you, Deepika ji. Thank you. And let me begin with introducing what AI in general is. You see, artificial intelligence, which we keep referring to as AI, is the ability of machine or computer programs to do tasks that usually need human intelligence, like understanding languages, recognizing images, making decisions, or solving problems. You see, all this requires some computer program to run, and that computer program runs through the hardware and where the computation actually happens. And the computation to happen, the electricity is utilized. So the larger the program, the bigger the program, the more computation is required, and more computation requires more electricity. And that's where now we are all accustomed to hearing ChatGPT and many other things. So these are large language models which require colossal amount of computation, and along with them we require data centers where data is housed. So together they need whole lot of energy. So it implies that a more deployment of data centers and large language models like an AI requires more electricity demand, and that impacts a country's energy requirement or electricity requirement. Saying that again, more AI deployment results in more electricity demand. And then all these AI systems, they require training, constant training and upgradation. So that again needs megawatt hours of electricity, and that pushes countries to invest more and more into energy producing systems and projects. Globally, when I say AI related electricity use is still less than or around 1%. In India is still less, but the production, if we just see the China electricity production today is almost 4 to 5 times of India's total electricity production, whereas US is producing more than twice of our electricity production, and that's where they are deploying more systems and having more such AI driven systems. Now, as the systems become smarter, the computation requirement goes up and it fuels requirement of electricity or the energy as such. So when we see this, the deployment of AI and associated infrastructure is happening at a much faster pace than the development of energy sources. And though we are not at the tipping point right now, but we may soon be at the tipping point where the demand will far outweigh the availability, and that would have reasons to find in the AI footprint.
Very true. Absolutely a brilliant way to set the stage with the core context. My next question is to you, Mr. Aman Gupta. AI systems, especially large-scale models, are energy intensive. How do you approach the design of AI infrastructure to minimize energy usage, and what breakthroughs are on the horizons?
Thank you, Deepika ji. Yes, AI systems, especially large-scale models, are indeed energy intensive, but innovators are actively designing for energy efficiency. For example, newer models like Meta's Llama or Google's Gemini are trained using optimized algorithms that reduce compute time without sacrificing performance. On the infrastructure side, it starts with smart design choices, like using specialized AI chips. Google's latest Trillium TPU, for instance, is nearly 5 times faster and 67% more energy efficient than its predecessor chips. The other big company in the AI game, Nvidia, and their latest Blackwell GPU is pushing efficiency forward as well. The latest offering was 2.5 times better performance per watt compared to earlier models. And not just the chips, CPUs, and GPUs, even the data center themselves are evolving too. Microsoft's latest report states that over 60% of its data center electricity now comes from renewable sources like wind and solar, and not through regular traditional energy resources. And they have a goal to hit 100% renewable energy for their data centers by end of the year. They are building systems that use energy more efficiently and wisely, like running tasks when the power grid is cleaner, using natural air instead of power-hungry cooling, setting up data center in places which has access to these renewable energy easily. I think looking ahead, exciting new technologies could make AI much more energy efficient. Some are inspired by how the human brain works, using far less power to get things done. Other newer offerings like Edge AI, for example, allow devices like your phone, your cameras, your sensors to have thinking capabilities themselves, so that we don't have to rely so much on these data centers and CPUs and GPUs, which just helps us in getting better and cleaner energy. The big idea is basically AI doesn't have to be on the cost of the planet. We are finding smarter ways to build it so that they are also more sustainable towards our planet and are more greener. Thank you.
Well, that gives an exciting perspective on the strategic landscape. Now coming to you, Mrs. Bhaskar, from an engineering standpoint, how is AI reshaping power grids, storage systems, and demand forecasting? What role does predictive intelligence play in real-time energy optimization?
That is an incredibly important question, because as we deploy AI deeper into our energy systems, we are not just talking about technology. We are talking about trust, safety, and resilience. First, on regularity frameworks. We need clear, enforceable standards that ensure AI systems in critical energy infrastructure are transparent, explainable, and auditable. AI cannot be a black box, especially when it is making decisions that can impact grid stability or public safety. Regulations must mandate testing and certification process much like we have for protection relays or SCADA systems. Cybersecurity is not negotiable. AI systems must be designed with strong encryption, intrusion detection, and fail safes that conduct against malicious attacks. Remember, a single AI driven failure or breach could cascade across the entire grid. Now, so regulatory frameworks must ensure redundancy and robust incident response protocols. Second, on ethical frameworks. We need to make sure that AI deployment aligns with human-centric values. This means that any AI decision that affects people's lives, like load shedding or tariff adjustments, should be subject to human oversight. AI should augment human judgment, not replace it. Transparency and accountability are key. Operators and consumers alike should know when and how AI is making decisions. This builds trust and ensures that we can step in and override AI decisions if needed. Now, where do we draw the line between innovation and precaution? In my view, it is about risk-based governance. For high-impact, safety-critical applications like grid balancing, protection systems, or blackout prevention, strict testing and oversight should apply, even if it slows down innovation. For lower impact use cases like optimizing energy efficiency or forecasting, regulatory sandboxes can allow for experimentation under controlled conditions. In short, AI can transform our grid, but only if we build it on a foundation of transparency, accountability, and security. At TNAB, we see this as essential, not optional, to truly harness AI's potential while safeguarding the public interest.
Well, such a valuable insight on how AI and energy must coexist. Dr. Bana, can you share how public-private partnerships are enabling large-scale deployment of sustainable AI infrastructure, especially in emerging markets?
Now that's my favorite. And let me share with you, PPP comes to rescue of most of such infrastructure needs. You see, the way AI deployment is happening, as I mentioned earlier, it requires a whole lot of upfront capital, capacity, technology, and policy framework, which are certainly deficient with the government of any country worldwide, and more so in the emerging markets. So, while the government can bring regulatory support, strategic support like land and grid access, and also share certain critical risks and approve revenue metrics, then also give access to the market which is AI infra, and private firms can contribute by bringing cutting edge technology, investment, management and operations, and they own the risks and then also earn return on investment. This collaboration accelerates the establishment of data centers, preferably green data centers. With green, I mean not the color green, but the ones which are running on renewable energy. The AI-ready cloud platforms and localized innovation hubs so that AI can deploy smoothly. There are examples of PPP based such AI infrastructure development in India, Kenya, and Brazil, where extensively you are having this AI parks where you can just plug and play. In the sense, if I wish to set up a data center, there are locations where all the other facilities which are required to set up a data center, like land, like permissions, like how the payments will happen, all those are already set up. So you just put in your money, sign certain agreements, and get going. Now, there are also support coming from the international institutions like World Bank, IFC, for certain countries and areas which are underserved and which require blended finance and many other type of supports. So things are happening, and PPP is a way to move forward. But let me also caution you, there are risks which are like there are governance gaps, there are unclear data sovereignty policies in many countries, and then there is a political and change of government kind of risks also, which will hamper the deployment of AI systems worldwide.
Interesting. It really highlights the scale and urgency of the issue. Mr. Aman Gupta, over to you. How can AI infrastructure be deployed in a way that doesn't deepen the digital divide or exclude communities from the benefits of clean energy?
Yes, there's a real risk that next-gen AI could deepen existing inequalities by concentrating infrastructure in wealthy regions, requiring high-end devices, or favoring languages and datasets from the global north. If we are not careful, the benefits of AI could bypass the very communities that stand to gain the most from it. To prevent that, we need intentional design and policy, building infrastructure where it's needed the most, prioritizing low-cost, accessible interfaces, and ensuring diverse voices and data shape how AI is developed and deployed. Some promising examples are already emerging. For example, in Kenya, Konza Technopolis is a government-backed initiative where AI and cloud infrastructure are being developed alongside renewable energy, thanks to partnership with Microsoft, G42, and the UNDP. It's a model of inclusive, sustainable tech development. Also in India, WhatsApp-based AI tools like Darli chatbot are reaching over 100,000 farmers in their local language, offering real-time farming advice on basic phones without needing broadband or expensive devices. These examples show that with the right intent and collaboration, AI infrastructure can be both powerful and equitable, bridging the device and not widening it.
Thank you. Well explained. Challenges do pave the way for innovation. Coming back to you, Mrs. Bhaskar, if you could fast forward 2035, what would a successful AI-powered low-carbon energy system look like? What's the one shift we must achieve in the next 5 years to get there?
That's a powerful question and one that speaks right to the heart of our vision for the future. If I fast forward to 2035, I see an energy system that is not just low carbon but genuinely intelligent, resilient, and sustainable. Imagine a fully interconnected grid where renewables, solar, wind, hydro, make up the backbone of our generation mix. AI would be seamlessly orchestrating supply and demand in real time, balancing generation with storage and flexible loads, while also predicting and managing every challenge from weather variability to an equipment failures. Storage systems powered by AI would act like a giant virtual battery across the grid, absorbing excess power during the day and releasing it at night or during peak demand. Demand side management would be highly personalized, with AI optimizing when we charge electric vehicles, run factories, or even heat water, always choosing the lowest carbon, most cost effective movement. And let us not forget predictive maintenance and digital twins. Every asset in the grid, from transformers to the wind turbines, would have a digital twin monitored by AI. This means less unplanned downtime, longer asset life, and fewer surprises. Now, what is the one shift we need in the next 5 years to get there? It is the integration of AI at the edge of the grid, at every node, every substation, every consumer meter. Right now, most of our AI applications sit at the control center level. But to unlock the true potential of a low carbon AI powered grid, we need to push intelligence all the way to the edge. This means deploying sensors, advanced meters, and local controllers everywhere, all linked by a robust, secure communication network. If we get that right in the near 5 years, if we build an AI ready infrastructure at every level of the system, then by 2035 we will have a grid that is truly smart, low carbon, and sustainable. And from where I stand at TNEB, that is not just a dream. With the right investment and a clear policy push, it is an achievable reality.
Thank you for that. Always good to hear solutions that are people-centric. Dr. Bana, from chip manufacturing to data center decommissioning, how are engineers embedding circular economy principles into AI infrastructure?
That's great. You see, world has come to realize that having a circular system or circular economy is more sustainable than just going on consuming without thinking of the repercussions. Now, just to recap, what is circular economy? It is an economic model focused on minimizing waste and maximizing resource efficiency. It emphasizes on reduce, reuse, repair, recycle, and regenerate. So, to employ the same thing to chip manufacturing, efforts are made to reduce rare earth mineral usage, improve yield efficiency, and design modular upgradable components that extend hardware life by just taking out the obsolete one and fixing the next one rather than changing the entire board. Companies like Intel and TSMC are exploring greener fabrication processes and closed loop material recovery systems. At the data center level, circularity shows up in modular construction, energy reuse like waste heat capture and server repurposing. The cloud providers now emphasize hardware refurbishment, life cycle extensions, and buyback arrangements. Software plays a critical role as well. And when it comes to decommissioning of the data centers, the components are increasingly recycled or reused within secondary market, while facilities are redesigned or repurposed for adaptive reuse. So circularity is not just a sustainability goal, it's becoming a cost-effective strategy for resilient long-term AI infrastructure.
That's such a hopeful take. Greener futures do look possible.
Yes.
Well, Mrs. Bhaskar, what kind of regulatory or ethical frameworks should guide the rollout of AI in critical energy infrastructure? Where should we draw the line between innovation and precaution?
That is incredibly important question because as we deploy AI deeper into our energy systems, we are not just talking about technology. We are talking about trust, safety, and resilience. First, on regulatory frameworks, we need clear, enforceable standards that ensure AI systems in critical energy infrastructure are transparent, explainable, and auditable. AI cannot be a black box, especially when it is making decisions that can impact grid stability and public safety. Regulations must mandate testing and certification process, much that we have to be production relays or SCADA systems. Cyber security is non-negotiable. AI systems must be designed with strong encryption, emulsion direction, and fail safes that protect against malicious attacks. Remember, a stage 8 drawn failure to breach could cascade across the entire grid.
Indeed, collaborations sound like the key of transformation. As we wrap up today's episode of Future Proof, one thing is clear: AI isn't just changing how we think, it's transforming how we power the world. From smarter grids to cleaner cities, from real-time predictions to real-world impact, the fusions of brains and batteries is more than a metaphor. It's a movement. A big thank you to all of you. We really appreciate for sharing such insightful perspectives, and to you, our listeners, for staying curious and staying tuned. Until next time, I am Deepika Upadhyay, anchoring off, and this is Future Proof, where we don't just talk about tomorrow, we build it. Namaste.
Namaste.